is actually, we can pause that. I'm not sure. Hello, Mr. Lesham is here. Yeah, it seems to be right. Good. Guys, we're back with the rations today, okay? We're going to solve equations with rational exponents. Can I just actually make it a little bit more tricky? Okay, we'll take it tricky. So here we go. Yeah, no, let's start one step ahead because sometimes it will be a bit tricky. So I've got an equation like this for x. Okay? Now, whenever you see this complicated thing with the root and exponent and all that, we straight away want to use a rule that we've learned. Okay? A to the power of m square root n is equal to a to the power of what? N over n. So we've got the power on top and the root below. So we convert roots and power into powers of a fraction. So in this case, 8 will remain there. And what are we going to write here? 8 to the power?
3 brackets.
3 over 5. 3 over 5. No brackets. 3 over 5. Okay? I'll pause. Right, now the question is, what do we do then?
I know.
Go on. I'll listen to you. Yeah. So what we don't want to do, we don't want to time it by 5 over 3, because that's not going to cancel anything. But what we are going to do is power it by 5 over 3. Because the rule, if you remember, a to the power of m power n is a to the power of m times n. Then we're powering it, but that means we're timing the exponents. Okay, that's going to cancel out, right? 3 over 5 times 5 over 3 is 1. But can I just write it like this? X equal 8. No, what do I need to do to the 8? The same thing. That's the rule of the equation. Whatever you do to one side, you must do to the other side. Okay? So can you see that when I'm timing those together, it's just going to be 1, which is what I want to be. Because I want just x. And then I can use a calculator. But you actually don't even need to. Okay? And I want you to get used to not using calculator for these things, because sometimes if this was not a number, if this was like a letter, then the calculator won't help you. How do we rewrite it? The same as that. What's that? Okay, we're going to have 8 cubic roots power 5. You see what I've done here? So first of all, I'll take the cubic root, and then I'll power it by 5. Why did I take the cubic root first? Okay, I could have also wrote it like this, 8 to the power 5, and all that cubic roots. But 8 to the power of 5 is a ginormous number. I can't expect you to know that one. Okay, so that's not useful. What is the cubic root of 8? You should know. It's 2. So it's 2 to the power of 5, which I expect you to know is 32. Okay, I'll pause here for questions. Chaps, so we're moving on. Okay. What I've changed here, the only difference is that I've got a negative number, but that is not going to be anything different, okay?
But how would that be okay though? Because then it would be negative square root of whatever, negative 3.
All I got to do is, I'm going to power it by what?
Negative 3 over 5.
That's it. So I can get rid of the minus.
Oh, okay.
Easy, okay? So x, that's going to cross cancel each other, equal 32 to the power of minus 3 over 5. We can do it. Let's just do it. We can use the calculator. I'm not going to be cross with you using a calculator, okay? Personally, what I would do is I would do like this. I will say, okay, let's take the cubic root, not the cubic, the 5 root of 32, and all that power minus 3.
Yes.
What is the 5 root of 32? 2. It's 2. So it's 2 to the power minus 3, which is 1 over 8. It's not minus 8, it's 1 over 8.
So you can put either...
I'll pause it, I'll hear you now, Chloe. So far everything is pretty easy, okay? And this is also not going to be too difficult, but it's going to be a little twisty. So x to the power 2, 3. Okay, what should we power by everything?
3 over 2.
3 over 2, obviously both sides. So that's going to be x equal 9 to the power of 3 over 2. You can put it in the calculator. It's 27 if I'm not mistaken. Just check me.
Yes, sir.
Maybe, yeah, because I'm doing a square root of 9, which is 3. 3 cubed is 27.
Yeah.
So x equal 27. X equal 27. And am I right?
What now?
Yeah? Should answer should obey the equation. Let's just check it out. Put it in your calculator.
Oh, I see what
If I hang on, I haven't seen anything. 27 to the power of 2 over 3. Just put that in your calculator.
It's still 9.
What happened? I'm just checking. I want to check. This is the solution, yeah? Does it come out as 9? It should come out as 9, yeah?
Yes.
Because it's
Yeah?
the cubic root of 27.
Yeah, cubic root of 27 shows 3 squared is 9. It's 9. That's good. Okay.
So what's the problem?
Right. What's the problem if Yadi's asking you? Absolutely. What's your problem? All right. Let's try another one. Put in, please, for me, minus 27 to the power of 2 over 3. Just, why would you do that? Just do it.
It's gonna be a
It's
negative.
gonna be a minus.
Just check.
Unknown, undefined.
No, check. Check.
So it's still 9.
Yeah,
So
check.
it's still 9.
It's still 9.
I
Let's
see
think
what
about
you
it.
mean.
Okay,
Right,
so
okay.
let me explain what we've just found out. Okay? Right, normally,
No,
guys, normally, when we try and solve an equation, as we did here, we get the solution, we're done, we're finished. For now, you don't always have to, well, you never have to do it. Well, you only have to do it when you have square roots. But I want to just check that it worked, and it did work. If I put 27 here, it came out as 9. And then just for the hell of it, I said, why don't we just try minus 27? And it still worked. In other words, there are 2 solutions. That's one solution, and the other one is x minus 27 27. So we had 2 solutions, and my job now as a math teacher is trying to convince you why there were 2 solutions. There were 2 solutions before. I could show you later, but there were. Now there were. Okay, let me just get you to see if you can guess why. Right, so I'm trying to convince you why we had 2 solutions here, okay, and we had only 1 solution before, right? Here, let's start actually with this. Come with me, okay? Let's go over here. Here, I have x to the power 5. This was an odd power, okay? X to the power of 1, or x to the power of 3, or x to the power of 5 will take a negative number and keep it negative. Look at this. Minus 2 to the power of 3, how much is that?
Negative 8.
Minus 8.
Okay.
Minus 2 to the power of 5 is?
32.
Negative 8.
Negative 32.
Yo, negative 8.
Okay. If I take 2 cubed, that's going to give you 8. 2 power 5 is 32. So an odd power, take a negative, gives you negative. Takes a positive, gives you positive. What about square? Okay? 2 square is 4. Minus 2 square is 4 as well. So a positive power takes a negative number and gives you positive. It takes a positive, gives you positive. So, let me hang on, question a bit. Let me finish this. Okay? Here, we had a an even power. Okay? So it took, even when we had a minus 27 here, that square here turned it into a positive. Okay? I'll try and repeat again. It's because we had an even number here. If we have an even number in the exponents, either that one or that one, it will take a negative number and turn it into a positive. Okay? Where before, you didn't notice it, but in all our examples, we never had even numbers. I made sure we didn't have even numbers. We only had odd. So the only answer, if this is positive, then this must be also positive. I will summarize it for you at the end. Don't worry if you don't get it at this point. I'll just pause. Guys, moving on. Right, I will summarize it to you all at the end because there's quite a lot of information we're picking up. Now, what I did different, I don't know if you noticed, we're back in odd numbers here.
Yes.
Both odd numbers, but what's the difference thing now? We actually have a negative 2.
But it's still going to be positive.
Let's see. Okay, what are we gonna raise the power by?
3 over 1.
3 over 1 or just 3 if you don't mind.
Yes, sir.
Okay? So I'm gonna write x equal to minus 2 to the power of 3. X equal
8.
Hold on.
8.
Minus
minus 8. Remember, q is minus 2 times minus 2 times minus 2. It's minus 8. Okay, hang on, I'll pause. Okay, just to finish it up, I mean, could we suggest maybe that x could be equal to 8?
No.
If I put 8 here, that somehow become negative? Definitely not, you're right. So there's just one solution here.
But so how do you know that?
Okay, I'll pause. Last example. You chatty today. Last example. Okay, right? What did I change now? Now I've got an even number. You can see that it doesn't matter if it's at the bottom. Okay? As long as you got an even number, that makes things different. And I've got a negative number here.
Oh, yes, sir.
What should I do first?
2 over 3 brackets.
2 over 3.
X equal to.
Guys, this is a good math lesson. Sorry.
Yes, I'm happy to hear. That's fantastic. Okay, so x equal what?
25.
2 over 4.
What?
No. Hey, what am I
Hold on.
thinking?
Okay.
I'm just going to pause. I just want to make sure I got the right number. So if we follow this procedure, let's just follow the procedure, okay? I'm not going to actually ask you even to put in your calculator. That will be the answer, okay?
Yes.
Are we happy with that?
Super.
Okay. Now, let's just try and yeah, this is difficult to explain. Hang on. If we were just doing it like this, without too much thinking, we will get actually an answer. And that answer is positive, right? Maybe tell me what it was.
2,92.
2,92, and it carries on, right? But let's just think about it for a second. If this is really the solution, then if I put 2,92, blah, 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 power 3 over 2,
It's not going to be the same.
can it be ever minus 5?
No.
No, it can't, because this is a positive number,
And a positive number.
and power, it's
So it gives you
power,
5.
it's going to give you 5, not minus 5. So you see, we have a problem. Okay? Now, I don't want to get in deep too much where the mistake was. Let's just revise. Let's just try and understand what was the problem. Not why is the problem, what is the problem. Only because I have an even number. And an even number, either here or there, that means you can't have a negative number here. I'm going to pause here and I'm going to put it all for you now on the table like they have in the book, and we're going to finish, okay?
Can I ask